Today we will learn queues. Whether it is a railway reservation counter or a movie theater or print job submitted to a network printer, there is only one way to bring orders to chaos. Form a queue. If you await your turn patiently, there is a more likelihood that you would get a better service. So queue is a linear data structure that permits insertion of new element at one end and deletion of an element at the other end. A queue is an ordered collection of items from which items may be deleted at one end called the front of the queue and into which items can be inserted at the other end called the rear of the queue. So front is the end from which we want to delete and rear is the end by which we want to add a new element onto the queue. Queue is an ADT, that is abstract data type. What is ADT we already learned in our previous video. Please consult our previous video. Queue follow the rule FIFO, that is first in first out, means the element which is added first will be deleted first from the queue. There are mainly four types of queue: linear queue, circular queue, D queues and priority queues. We will learn each and every queue in separate video. Today we will learn linear queue. Linear queue. The data structure of linear queue is, first you have to define one user defined structure queue. Say the name of the structure is queue. You have to write the keyword struct. The name of the structure is queue. It is an integer queue. So I have to declare one integer variable item, and max is the maximum number of elements that this particular queue holds. So one integer array item and max is the maximum number of elements that this particular queue holds. Two integer variables are there, rear and front. Rear is the inserting end and front is the deleting end. And here struct queue means here I define one variable of type struct queue. So queue is the object or the variable of this structure. Okay. In case of linear queue, there are four primitive operations. We have to learn each and every primitive operation in detail. Four primitive operations are empty to check whether your queue is empty or not, full to check whether your queue is full or not, insert means I want to insert some element onto this queue, and remove means I want to delete or remove some element from the queue. Now see how linear queue works. In case of linear queue, there are two ends. One is rear end is the inserting end, and front end is the deleting end. Now this is an integer queue, all elements are integer. So I want to insert and delete these elements. Okay, these are all integer elements. Initially the value of rear is -1 and front is 0. So when the queue is empty, I have to initialize value of rear as -1 because no elements are there, and if there is at least one element, then front is 0, means then you can delete, so front is 0. I repeat, if there is at least one element, then you can delete, so front is 0. So start insertion. First I want to insert 2. First you have to increase rear becomes 0, insert 2. Again increase rear 1, insert 4. Increase rear 2, insert 8. Increase rear 3, insert 10. Increase rear 4, insert 13. Now see, in this situation value of rear is max -1. What is max? Max is maximum number of elements that the queue can hold. So here value of max is what? 1, 2, 3, 4, 5. 5. So value of max is 5. So value of rear is 4 because rear starts from 0. So when the value of rear is max minus 1, we can say that our queue is full. Now see, value of front is still 0 because no element is deleted yet. Okay. Now it comes to deletion. Now we want to delete. So first see what is the deleting end. Deleting it, this one is the inserting end, rear end, and deleting end is the front end. What is the initial value of front? Front is 0. So initially front is 0. Now you have to delete. So delete 2 because Q follows FIFO rule. First inserted element will be deleted first. So first 2 will be deleted. So delete 2, then you have to increase front. Okay. Again delete 4, increase front. Delete 8, increase front. Delete 10, increase front. Delete 13. So when the value of front equals to max minus 1, then we can say that queue is empty. So when the value of front is max minus 1, we can say queue is empty. Now I write one function to check whether our queue is empty or not. If the queue is empty, then it returns 1. If the queue is not empty, it returns 0. So it returns either 1 or 0. Both are integer. So the return type is integer. Function name is empty. And struct queue star queue means here I am passing address of this structure queue. Okay. See, when I write int I, means what? I is an integer variable. When I write int star a, means a can hold address of any integer. So when I write struct q, say p, means p is a variable of type struct q. So when I write means what? Struct q star q means what? Q can hold address of any struct q type variable. So Q can hold address of this structure. Same way, int I and int star a, in the same way struct q p, struct q star q. So struct q star q means Q can hold address of this structure. Now see, initially rear equals to -1 because no elements are there. Rear end is the inserting end. No elements are there, so initialize rear as -1. And front is 0 because we can delete when there is at least one element. So we initialize front as 0. So rear is -1, front as 0 is the initialization condition, that is the empty queue. So when front minus rear is 1. See, 0 minus minus 1 means 1. So when front minus rear is 1, then we can say queue is empty. Otherwise, queue is not empty. So when front minus rear is 1, then we can say queue is empty, then return 1, otherwise return 0, else return 0. Now see, this rear and front, these two integer variable is under this structure. So I can't directly access these variable because they are the member variables of this structure. So to access these elements, you have to use arrow operator because here we are sending the address of this structure. So q arrow front minus q arrow rear is 1. If it is 1, then we can say that our queue is empty, otherwise our queue is not empty. Now your task is to try to write full function for linear queue by your own. Pause this video, try to write full function by your own. Now function full. If your queue is full, then it returns 1. If your queue is not full, it returns 0. So it returns either 1 or 0. So the return type is integer, function name is full. Again, we are passing the address of the queue. So struct queue star queue. Now see, what is the condition for full? See, if this queue holds maximum number of element, here it is 5. So the value of max is 5. So if the value of rear is max minus 1, I repeat, say the queue holds max number of element. Means maximum number of element here queue can hold is 5. So here in this case max is 5. So when rear is 4, we can say that queue is full. So when the value of rear is max minus 1, we can say the queue is full. Then you have to return 1, else return 0. Now because the rear variable is the variable of this structure, so you have to write queue arrow rear because we want to access this rear variable by the address of this structure. You have to write queue arrow rear. So if queue arrow rear equals to max minus 1, we can say queue is full, otherwise return 1, otherwise return 0. Insertion. I want to insert some integer element into this queue. Which one is our inserting end? Rear end. Through this end, we want to insert. Initially, rear equal to minus 1 when the queue is empty. Now we want to insert 2 here. So first we have to increase rear. Rear is 0, insert the element. So first increase rear, then insert element. So I have to write item 0 is equals to what? Is equals to 2. Now what is the value of rear here? Rear is also 0. So I can write rear is also 0. Sorry, rear is also 0. So I also can write item rear is equals to 2. Is it? Because see, rear is also 0 here. Rear is also 0 and item 0 is 2. So rear is 0. So I can write item rear equals to 2. Second time, when I write rear plus plus, second time when I want to insert this 4 here, insert this 4, second element here, rear plus plus. So what is the value of rear now? Rear equals to what? Rear equals to 1 now. Okay. So item 1 is 4. Okay. So I can also write item rear is 4. Okay. Now third time it is 8. Okay. Say each time when we call this function insertion, say I want to insert the element, the name is x. So I can also write item rear is equal to x. Now see, item rear, all are the elements of this structure queue. So to access this element, you have to write q arrow item q arrow rear is equals to x. So in this way, you have to write the code. So See the code first. So function name is insert. Here I am passing the address of this structure. So struct q star q. Q can hold address of this structure. And the element which we want to insert, say it is x. Now before insertion, you have to check your q is already full or not. So call the function full by passing the address of this structure, q structure. This is our full function. We already learned about full function. So we are passing the address here. And if that function returns 1 means what? If this function returns 1 means it is impossible to insert. Otherwise, first you have to increase the rear, then insert the element. So increase the rear. So first increase rear, q arrow rear plus plus, then insert the element. So q arrow item, q arrow rear equals to this x. Second time, for the second element insertion, again you have to call this insert function. Now don't forget to write this q arrow because rear item are the elements of this structure q. So don't forget to write this q arrow. First you have to increase the rear, then insert the element pointed by rear. Now your task is to try to write remove function by your own. Pause this video, try to write remove function by your own. Now deletion. In case of deletion, Q follows which rule? FIFO rule. So first inserted element will be deleted first. Okay? And which end is the deleting end? Deleting end is the front end, this end. Okay? So from this end we have to delete. Initially when the queue is full, we start deletion from this end. Okay? We start deletion from this end. First you have to see that front is, we already initialize front as 0. So front is 0, front point here. So first delete this element, then increase front. I repeat, first delete the element, then increase front. Delete the element, then increase front. Because I initialize front as 0. So first delete the element. Delete the element means what? Item 0. Say there is one variable y. In this variable, I just store this 2, the deleted element. So y equals to 2. I can also write it is item 0. I can also write y equals to item 0. But what is the value of front? Front is also 0. So I can also write y equals to item front, because see front is 0 and it is item 0, item front. So item front will be stored in y and I can return this y where the deletion function called, from where the deletion function called. Second time, then I have to do what? I have to increase front. Front becomes 1. So front plus plus. Okay. Now increase front means front now point here. Now y equals to, say it becomes 4. So y equals to 4. 4 means what? 4 means y equals to item 1. Front is also 1 here. Here front is 1. When front is 1, then I can write y equals to item front, because front is 1. Now again front plus plus in this way. Okay, so both item front are all in this are all the elements of this queue structure. So you have to access these, you have to write queue arrow because we are passing the address. So queue arrow item, queue arrow front, and here also queue arrow front plus plus. In this way you have to write the code. So see here, next time you have to increase front. Front is 1, delete the element. Increase front, front is 2, delete the element. Increase front, front is 10. See the value of front and item 3. So I can write item front. Okay. Delete the element. Increase front, delete the element. Now the queue is empty. When the queue is empty, we can say that it is impossible to delete further. So see the code. So queue function. In case of queue function, the return type is integer. Why so? Because it is a integer queue. The removed element is integer and that element will be returned from where this queue function is called. So the return type is integer. And here we are passing the address of the queue structure. Now first you have to check whether your queue is already empty or not. If your queue is already empty, then it is impossible to remove further any new element from the queue. So call the function empty by passing the address of this queue structure, and if this function returns 1 means your queue is empty, then exit 0 means come out from the program. Otherwise you have to take that particular value pointed by the queue front and store that value to the variable x and return that value and then increase front. I repeat, first we have to store that value pointed by the queue front and store that value to the variable x and return that value from where this queue function is called and then increase the front. In this way, queue function works. So see the coding. First see here, I define one macro max 6. So value of max is 6. These are those four primitive operations of the queue. Empty operation means to check whether our queue is empty or not. Full to check whether our queue is full or not. Insert means I want to insert some element into the queue, and queue remove is delete some element from the queue. And this is the queue structure. Okay, there is one integer array int item max. Array size is 6 here because max is 6. Int rear and front, two integer variables are there, rear and front. This is the object of this queue structure, struct queue. Now I initialize, when the queue is empty, I initialize front as 0 and rear as -1 when the queue is empty. Start one do while loop, do, and this loop is infinite loop while 1, this loop continues. Okay, there is one index, supply your choice, user give choice number 1 is user want to insert, choice number 2 is remove or delete from the queue, choice number 3 is see the recent position after some insertion and deletion, what is the current position of your queue. Number 4 is exit, means come out from the program. Number 5 is default, if user press any wrong key. Now take the choice, okay, from the user. Now here we use switch case control statement. Switch choice. If it is case number 1, then take the element which you want to insert. Case number 1 is insertion. Okay. So take the element which user want to insert. Say the element is x. Now call the function insert by passing the address of the queue structure and the value which the user want to insert. Okay, so go to that function. Okay, in this function here we are passing the address of the queue and the value user want to insert. Call the function full queue to check whether your queue is already full or not. If it is already full, then it is impossible to insert. Otherwise, you have to increase the rear and insert the element pointed by the rear. Okay, and full function is already written. This is our full function. Here also we are passing the address of the queue, and if the rear is max minus 1, then the queue is full, then it returns 1, otherwise it returns 0. Next, case number 2. Case number 2 is remove, means delete some element from the queue. So this is call the function queue remove by passing the address of the queue, and the removed element will be stored in the variable y. I declare y as a var here. I declare y as an integer variable. So then print the value of y. And don't forget to write this break, usual case control structure. Okay. So where is our queue remove function? This is our queue remove function. We are passing the address of the queue, call the function empty queue. If the queue is already empty, then it is impossible to remove any element from the queue, then exit. Otherwise, first take the elements pointed by the front and store it to the variable x. I declare x here, and then return x and then increase front for removal of next element. Okay, and see where is our empty function. Empty function is here. Here if the difference between queue front minus queue rear is 1, then our queue is empty, then it returns 1, otherwise returns 0. Here also we are passing the address of the queue. Now case number 3 is what is the recent position now. So from rear to front, I start one for loop. Value of I start from rear to front, I decrease I, and each time I print the value of item. In this way, I can see what is the recent position of our queue. Case number 4 is exit, means close your program, and case number 5 is if user press any wrong key, that is the default. Okay. Now when I run the program, supply your choice, say 1, I want to insert. Okay, so I insert 11, again I want to insert 22, again I want to insert 33. Now see the recent position. This is our recent position, 11, then 22, then 33. Now I want to remove. Now tell me which element should be removed first. Because queue follow FIFO rule, so first inserted element will be removed first. So 11 will be removed first. So press 2. So the removed element is 11. Now I want to see the recent position. Again press 3. See the remaining elements are 22 and 33 in the queue. Now again I want to remove. Again press 2. The removed element is 22. Now see the recent position 3. It is only 33. Now press any wrong key, say 45. It is wrong key. And case 4, close the program. Okay. So in this way, queue works. Now your task is you have to do or you have to execute this program by your own. See the code, pause this video, see the code, and execute this program. Now see the code. First, include header files and macro. These are prototype declaration. Then queue structure. then main, variable declaration and initialization. Then start do while loop. Take the choice. Then switch case control statement. Close while do while loop here. End of main. Empty function. Full function. Insert function. And remove function. Now try to do it by your own. Now see, in case of linear queue, first you have to increase rear for insertion, increase rear insert element, increase rear insert element, increase rear insert element, increase rear insert element. In this way you have to do your insertion. Now your queue is full. So what is the condition of full? That rear equals to max minus 1. Okay. Now in case of deletion, first, because queue follows FIFO rule, first delete the first element, means it follows FIFO rule, increase front. Delete second element, increase front. Delete second element, third element, increase front. In this way you have to delete. We already learned this thing. Now the situation is that at this moment, what is the value of rear and front? Rear is max minus 1, rear is max minus 1, but front is also max minus 1. See, rear is max minus 1, so queue is full, that is the condition of full. So we can't insert further any new element into this queue, though the queue is still empty. So what is the disadvantage of linear queue? The main disadvantage of the linear queue is that we may reach the absurd situation where the queue is empty, but since rear becomes max minus 1, we can't insert any element further into this queue. To remove this difficulty, we have to learn circular queue. If it is possible that after going here, both rear and front is max minus 1. If it is possible that start inserting from the beginning again, then this difficulty may overcome. For this reason, you have to learn circular queue. I repeat, if it is possible, see here, rear equals to max minus 1, front equals to max minus 1, queue is empty. If it is possible, because rear equals to max minus 1, we can't insert any new element into this queue. Now if it is possible that we can start inserting again a new element here, if it is circular, then this difficulty may overcome. So for this reason you have to learn circular queue. This is your programming assignment. Try to write C program to implement the primitive operations of linear queue. These are your homework. Choose the correct option and answer me in the comment section what is the correct option. I am waiting for your reply. For getting more and more updates, please subscribe my channel. That's all for today. Thank you.